Jupiter. The very name evokes a sense of awe and wonder, a beacon in the night sky that has fascinated humanity for millennia. This celestial giant, the largest planet in our solar system, has captivated astronomers for centuries, inspiring countless observations and studies. Its swirling clouds and colossal storms paint a picture of raw, untamed beauty, a dynamic atmosphere that never ceases to amaze. Jupiter is a gas giant, a massive world composed primarily of hydrogen and helium, the lightest elements in the universe, yet it holds a mass greater than all the other planets combined. Its immense size and gravitational pull have shaped the solar system we know today, influencing the orbits of other planets and even protecting Earth from potential comet impacts. Jupiter's story is one of immense scale and fascinating contradictions, a planet of both chaos and order. It is a world of extremes, where swirling storms rage for centuries and auroras dance across its poles, creating a mesmerizing light show. Its moons, a diverse collection of worlds in their own right, offer tantalizing hints of potential habitability, each with its own unique characteristics and mysteries. Join us as we embark on a journey to explore Jupiter, the king of the planets, and uncover the secrets of this majestic giant. Jupiter's sheer size is difficult to comprehend. With a diameter of roughly 86,881 miles, it would take over 1,300 Earths to fill its volume. This makes Jupiter about 11 times wider than Earth. To put it another way, if Jupiter were the size of a basketball, Earth would be about the size of a nickel. This massive planet rotates incredibly fast, completing a full rotation on its axis in just under 10 hours. This rapid spin contributes to Jupiter's slightly flattened shape, making it wider at the equator than at the poles. Despite its enormous size, Jupiter has a relatively short day. However, a year on Jupiter, the time it takes to orbit the Sun, is much longer than an Earth year, lasting about 12 Earth years. Jupiter's atmosphere is a mesmerizing spectacle of swirling clouds and vibrant colors. Unlike Earth, Jupiter doesn't have a solid surface. Its atmosphere is a deep, turbulent ocean of gas, primarily hydrogen and helium. These gases are constantly churning and mixing, creating the distinctive bands and zones that encircle the planet. The light-colored zones are regions of rising gas, while the darker belts are areas where gas is sinking. These alternating bands of rising and falling gas create powerful jet streams that race around the planet at speeds of up to 400 miles per hour. The colors we see in Jupiter's atmosphere are thought to be caused by trace amounts of other compounds, such as ammonia ice, water ice, and sulfur compounds. Perhaps the most recognizable feature of Jupiter's atmosphere is the Great Red Spot. This massive storm system, larger than Earth itself, has been raging for at least 400 years. The Great Red Spot is an anticyclone, meaning it rotates counterclockwise in Jupiter's southern hemisphere. The Great Red Spot is not the only storm on Jupiter. Numerous smaller storms, some white and others brown, dot the planet's atmosphere. These storms can last for years or even decades, merging with and consuming each other in a constant dance of atmospheric turbulence. Jupiter's extreme winds, driven by the planet's rapid rotation and internal heat, whip these storms into frenzies of activity. Section 5. A miniature solar system. The moons of Jupiter. Jupiter boasts a vast system of moons, with at least 79 confirmed satellites orbiting the gas giant. These moons create a dynamic and complex gravitational dance around the planet. These moons range in size from small, irregularly shaped bodies to Ganymede, the largest moon in the solar system, which is even larger than the planet Mercury. Ganymede's immense size and unique features make it a subject of great interest for scientists. Jupiter's four largest moons, Io, Europa, Ganymede, and Callisto, are known as the Galilean moons, after their discoverer, Galileo Galilei. These moons were first observed by Galileo in 1610, revolutionizing our understanding of the cosmos. These moons are fascinating worlds in their own right, each with its own unique characteristics and stories to tell. They offer a glimpse into the diverse and dynamic nature of celestial bodies. Io is the most volcanically active body in the solar system, with hundreds of volcanoes, some of which are constantly erupting. Europa is thought to harbor a vast subsurface ocean, which could potentially support life. The icy crust of Europa hides a liquid water ocean beneath, making it one of the prime targets in the search for extraterrestrial life. Ganymede has its own magnetic field, a rare feature for a moon, which adds to its intrigue and scientific importance. And Callisto is a heavily cratered world that may hold clues to the early solar system. Its ancient surface is a window into the past, offering insights into the history and formation of our solar system. Section 6. Ganymede and Europa. Worlds of intrigue. These two moons orbiting Jupiter are not just celestial bodies, they are worlds filled with mysteries and potential. Of all Jupiter's moons, Ganymede and Europa hold particular fascination for scientists. Their unique characteristics and potential for harboring life make them prime subjects of study. Ganymede, as the largest moon in the solar system, is a world of superlatives. Its sheer size and unique features set it apart from other moons. It is larger than the planet Mercury and is the only moon known to have its own intrinsic magnetic field. This magnetic field is a rare phenomenon among moons. This magnetic field creates auroras, similar to Earth's northern and southern lights, around Ganymede's poles. These auroras are a stunning visual display, offering clues about the moon's magnetic environment. Europa, on the other hand, is a world of tantalizing possibilities. Its icy exterior hides secrets that scientists are eager to uncover. This icy moon is thought to harbor a vast, salty ocean beneath its surface. The idea of an ocean beneath the ice is both intriguing and exciting. This ocean, potentially containing more water than all of Earth's oceans combined, is a prime candidate for extraterrestrial life. The sheer volume of water increases the chances of finding life. The presence of water, along with potential sources of energy and chemical building blocks, makes Europa one of the most exciting targets in the search for life beyond Earth. Scientists believe that these conditions could support microbial life, making Europa a focal point for future missions. Section 7. Unlocking Jupiter's Secrets. Missions of Exploration. To unravel the mysteries of Jupiter and its moons, scientists have sent numerous spacecraft to explore this distant world. NASA's Juno spacecraft, currently in orbit around Jupiter, is providing unprecedented insights into the planet's atmosphere, magnetic field, and internal structure. The European Space Agency's JUICE mission, scheduled for launch in the 2020s, will focus on studying Jupiter's icy moons, particularly Ganymede, Europa, and Callisto. JUICE will investigate the potential habitability of these moons, searching for evidence of liquid water and the building blocks of life. These missions, along with observations from Earth-based telescopes, are helping us to piece together the story of Jupiter and its place in the solar system. Section 8. The Guardian Giant. Jupiter's influence. Jupiter's immense gravity has played a profound role in shaping the solar system we see today. During the early solar system, Jupiter's gravity helped to clear out debris and shape the asteroid belt, preventing the formation of another planet between Mars and Jupiter. Jupiter's gravity also acts as a shield, deflecting comets and asteroids that might otherwise pose a threat to Earth. While Jupiter can sometimes send objects hurtling towards the inner solar system, its overall influence has been to make the solar system a more stable and hospitable place for life to evolve. Section 9. Jupiter by the numbers. Key facts and figures. Mass: 317 times the mass of Earth. Volume 1,321 times the volume of Earth. Diameter 86,881 miles. Rotation period 9.93 hours. Orbital period 11.86 Earth years. Surface pressure 24 times Earth's atmospheric pressure. Temperature minus 234 degrees Fahrenheit or minus 145 degrees Celsius. Jupiter's orbit around the Sun is slightly elliptical, meaning its distance from the Sun varies throughout its year. At its closest point, Jupiter is about 460 million miles from the Sun. At its farthest point, it is about 507 million miles away. Section 10. Conclusion. A continuing journey of discovery. Jupiter, with its swirling clouds, colossal storms, and diverse collection of moons, continues to captivate our imagination. This gas giant, a world of extremes and endless fascination, holds clues to the formation of our solar system and the potential for life beyond Earth. As we continue to explore Jupiter with increasingly sophisticated spacecraft and telescopes, we can expect to make even more groundbreaking discoveries.